the structure of the presentation, introduction and scope of the research. I will give 2 or 3 minutes to Abu Dhabi University because they deserve it. They allowed me to come and talk, and also they finance the research. 3, I will talk about the absorption and the transport phenomena of heavy metals in soils. It's similar to transport phenomena through porous media, and we are taking here soil from UAE. And then I will talk about the experimental setup and procedure and some results. We discuss them, and then I give conclusion. Here is the introduction. You know that soil, when it is contaminated by heavy metals, which is hazardous for human, animals, and health, and it is in general an environmental problem. How it comes? It comes from human activities. That's mining, industrial emission, disposal or leakage of industrial waste, application of sewage sludge in agriculture as a fertilizer, and the use also of pesticides. So this is a real problem today, and we have to find a solution. A solution, it should be efficient, and it should be also affordable. Money talks. And I am taking here, at the bottom, you can see some of the references I am using. Here, we have done some research on zinc, cadmium, and lead ions. These are most difficult contaminants to remove from soil. And we are using natural materials, plants, because today everybody is talking about protecting the environment and green technology. So we are using some extracts from plants to do this investigation. So the process we will in this research, we introduce a process for removing of these harmful elements from the soil of the United Arab Emirates. So this technique is low cost because it comes from plants, and the plants are just growing everywhere, and they grow in harsh climate, very high temperature, low water. And these 2 plants I am using, I will show you how we use them. And now this is our university, small university, about 7,000 students, and is focused on engineering, and it's located in Abu Dhabi University, Abu Dhabi city, the capital of UAE. And here are our graduation ceremony last year, and you can see we are small community, but we are doing a good job. Here, these are 2 of my students. They present the research in Thailand, in the International Conference of Material, and they got awarded, and it's worth to talk about them today. Finish. Now, I will talk about the theory of transport of chemicals. So I will do quick introduction, but if you want to see all the steps, you consult just my publication in the American Journal of Environmental Protection 2015. So we have here a driving forces, which is just the concentration difference between the equilibrium and any concentration which is far from equilibrium. And we introduce what we call the surface excess, which is related to the measure of adsorption. And this equation 1 is just the excess at equilibrium, which is the excess at any time multiplied by the driving force. And we can relate also the monomer absorption model, which I am taking in account, and the surface excess, and we express it as follows in equation 2. And then we relate all this with the selectivity, because some some heavy metals are the soil can capture or can select from others. So we talk about selectivity, which is an important factor in separation processes. Then we combine them. All these are just a theory. No need to go there. But if you want, you can consult the publication. It's given in details. And this is the governing equation, which is a very high equations, and we have to solve it using some computing or programming. So we solve this equation, and we are taking this equation in a column of soil. So we have soil. We take a column of soil, and we inject contaminated water, and then we see absorption and desorption. The absorption, how our soil is fixing the contaminant, and the desorption, how to wash it. When we wash, we do it in next slide here. We do it in two ways. So I am taking surfactant X and surfactant Y. Surfactant X is just Anasastatica aerochantica, which is the scientific name of the plant from where we extract the surfactant. And the second one, which is Y, it's Areophis logopoid. These are names very coming from Greek, but when you see the picture, you can recognize them. So let's look at here. This is the absorption. So here we reach what we call saturation, and here the model, and you see that the data are fitting the model. And here is the desorption when we are cleaning. So we are cleaning with water containing the surfactant, and we can see here the model is here, and this is our point, and we are taking here what we call the dimensionless concentration. And the other side here, we have surfactant X, and we do the same thing, and we can compare. Here are the two plants. This is plant X, and this is plant Y. These are growing in the desert. They can grow in any desert, and they grow in Qatar, in UAE, in Saudi Arabia, in North Africa, and these are also desert. So they don't need a lot of water. And if you look at this one, and I was amazed by the behavior of this plant, it's in the desert where there is no rain, but it's full of water. So I was just, I said, maybe we can use this because it's resisting to harsh climate. Maybe you can use it for something useful. And here, how the mechanism of the plants, how to remediate. We have two phenomena: the phytostabilization. So some plants have the ability to immobilize the metal and with absorption to the roots. So they take the metal from the soil and take it to their roots. The other one, they take the metal from the soil and take it to the leaves. And this phenomena here is now, it's like a novel approach to clean a polluted metal soil. And here is the plant. I have some literature about the plant. It is 15 centimeter height. It has some flowers, and it looks very nice. It's not harmful. It's a nice plant, but it grows in harsh climate in Iran, in UAE, in North Africa. The other one also the same thing, and we have some literature about these two plants. How the procedure here, what we do, in order to observe both absorption and desorption, we built a column. We fill the column with the soil, and we inject contaminated water, followed by fresh water to clean. This is the first step. The second step, we repeat A, but in order to use distilled water, we use water with a mixture of this surfactant extracted from the two plants. So we can compare, this is without surfactant and this is with surfactants. And the difference can give me an idea about how I am cleaning my soil. Experimental work. So we have a glass of a column here, and we use only pressure, hydrostatic pressure. We don't use pressure. And we have natural carbonate rock. We collect it from Al Ain, which is just a town in UAE, in Abu Dhabi, near Abu Dhabi. So we crush this carbonate and we make it like small, and it is 15% crunched. So we have a voidage, and then we let the inlet. We know the concentration of the inlet column, and we measure the outlet. When we reach what we call breakthrough, we stop, and then we do the cleaning with water, and then with water plus our surfactants. Here, how to prepare. So we have our soil, we crunch it, and here we clean. First we clean the water, the soil. We clean it. It's like nothing in it, and then we contaminated it, and then we clean it again with water, and then the second time we clean it with our surfactant. How to prepare? So we take the leaves of the plant, and then we wash them, we dry them, and we ground them as a powder. And here we prepare a solution. And since I said I'm taking only zinc as an example, because we don't have time, and then we do here, we prepare in two flasks, one flask acidic flask, and the other one is basic flask. So we put just some 2 or 3 drops of acid here. We put an acid here. We put a base, and to see the effect of pH. And then we repeat. This is our main. And then we put them in flask. This is my students were doing it. And here the surfactant, how we extract it. And you see here, this is surfactant X, and this is surfactant B. And you can see the difference and we can see here bubbles. And this foam can resist. It's very stable. And I was amazed, it can stay more than 24 hours. And here I put them in these are my 1 and 2. We combine them and we put them in the fridge. And when we want them, when we use them, we want them to use, we take them from the fridge. Here, this is our lab, and here just how to measure, to see the foam, because the foam is playing a big role in the cleaning. It's like any detergent, by the way. We are not inventing anything new. And this is a column. So we have here our surfactant, and we inject here some air. So we have bubbles, and we collect here. This part here, I will not cover it because it needs, maybe next time we will have the opportunity to talk about how the foam is taking the heavy metals. Now, analysis. So how we take these are the items, 15 and the zinc sulfides distillation, and these are just procedure. Here, this is the most important slide. So I am taking here the zinc. So the blue here is X in acidic, this in basic, and this one in acidic and basic, which is our surfactant X and Y. And you can see here the concentration here, and we can see here the blue one, which is the acidic, and we can see here the basic, and we can see a difference here that it works in acidic phase. but they are okay. The other one here, they are similar. So for there is no effect of acidity, but here there is an effect. But this is when the concentration is high. But when the concentration is low, we can see here is a change in, I don't know what's happening, but it needs more investigation. So here, like the same level here, and this is gone. And then we can, and we have seen, and when we vary the concentration, and we can see the same pattern. So here are some comments I am doing here, and the next slide here, the conclusion. We can say that surfactant X is more effective in absorbing zinc than Y, and also it gives, is it time? Okay, here are some references, and here,
yeah, please go ahead.
Okay, here are some the references I am using, and here further research we will conduct for cadmium and lead, and further research also for forms separation.